Okay, so let's start the next topic then. This is a relatively short topic, to be honest with you, so we should get it done relatively quickly compared to how long we spent on the other themes, okay? So we're going to start something called sequences and series. And we're going to start off fairly basic, but it will build up fairly quickly, okay? So hopefully by the end of this week, we'll be looking at things like binomial series and Taylor series as well, okay? But first of all, let's understand what we mean by sequences and series. And I'm going to give you 3 definitions. I'm actually going to start off not with either of these. I'm going to start off with what is a set. So a set. Now, does anybody know, like, how would you define a set? What is a set?
That kind of set?
Yeah, good. So you can definitely represent them using circles, so a Venn diagram, okay, where this might be set A and set B. But what is a set? That still doesn't answer my question. That's how you can represent a set visually.
It must represent the intersection as well as union.
Mm-hmm.
It means
I mean, you're just saying words to me without really describing what a set actually is. So you've used words like intersection and union and complement. But what is a set?
Element.
Good, so a set has elements in there. So a set would just be a collection of objects. Okay, now because we're dealing with sort of this in a mathematical context, a collection of objects is usually numbers, okay, but it doesn't have to be. It doesn't have to be. So, for example, you might have a set of clothes, okay, or you might have a set of cutlery, or you might have, I don't know, a furniture set, right? A set is just a collection of objects, okay. And you're right, Sanjay, you can absolutely represent sets using Venn diagrams, okay? So, for example, set A might be all the prime numbers under 30. Set B may be all of the odd numbers, okay? This bit in the middle would be numbers which are prime and also odd, okay?
if it's a complement, then it will be set.
Yeah, absolutely. Yeah. So complement means not in that set.
Oh.
Okay, fine. So that's what a set is. Now, the reason why I started off with a set is because you may just have something like this. So this might be an example of a set. Now, we usually put sets in curly brackets like this, okay? So it might be, for example, 3, 9, and 1, okay? Now, you notice here that this set doesn't have any particular order. Like, we haven't defined any order here yet, okay? A set is just simply a collection of objects. And each object in here we tend to call an element, okay? So now I think we can go on and we can define what a sequence is. So what is a sequence? Based on the fact that a set is just a collection of objects, what is a sequence?
Order.
Sorry?
Order.
Yeah, fantastic. So we're putting some order to this set. So an ordered set. So we're building on this definition now. So a set is just simply a collection of objects, like 3, 9, 1. A sequence has to have some order associated with it. So for example, I may write 1, 3, and 9. That may be a sequence because I've now put it into some kind of order. Okay, so it goes 1, 3, 9. Okay. Would you be happy? I could have also written 9, 3, 1. My question is, would these two sequences be the same? Now, they've got the same numbers in. Are they the same sequence? Why not?
One is in increasing order, another is in decreasing order.
Okay, good. So it's coming back to this. A sequence is about the order of that set, okay? So because I've written these two things in different orders, they must be different sequences. Is that okay? Okay, fantastic. So that's what a sequence is. It's just an ordered set. What's a series?
It's like exponential.
So an exponential series
It's
or a power series.
power series.
Okay, so maybe you've heard these words before, but how would you define a series?
In a continuous flow.
But isn't a sequence continuous as well? What's the difference between a sequence and a series? So a series is just simply taking a sequence and it's adding all the terms together. Okay, so we say the summation of terms in a sequence. Okay, so it's the summation of a sequence, if you like. Okay, so it's literally what happens. I give you a sequence. If I ask you to add all of the elements together, then you're producing a series. Okay, so it's important to understand the distinction between a sequence and a series. Sequence is just a list of numbers, an ordered set. Okay, a series is what happens when you add all those terms in a sequence together. Okay. Now let's start putting a little bit of terminology around this. So let's suppose I have, by the way, I will just say this. What happened if I did this to my sequence? So I added 3 dots on the end. What does that mean? If I added 3 dots to the end of my sequence. Likewise, I could add 3 dots to the end here. What do those 3 dots mean in the context of this?
It's going.
Absolutely, it carries on forever. Okay, so it carries on in the same way forever. So it's a nice way to continue. Okay, so if you see me writing those 3 dots, it means that it is an infinite sequence. Or if you see me writing the 3 dots in the context of a series, it means it's an infinite series. It carries on forever. Okay.